Hello everybody, welcome back to another episode of Classic Arcade Repairs. Sean here with you. Just getting to looking at the next job in line, and I thought I would film this one because it's always fun doing these. This is a vector monitor. This one is a CinemaTronics vector monitor. And this one comes from Brian, and it says, "Greetings, I was referred to you by blah blah blah. Star Castle monitor recently took a dive, and it appears to be horizontal collapse," he says. Okay, well, this is a CinemaTronics monitor, so has no horizontal deflection. So it's got a line up the middle with nothing horizontal. So that should be a pretty easy fix, but we'll go through. We'll test everything. We'll upgrade where needed. We'll do maintenance work on the thing and do that. So let's go ahead and let me get situated here, put some stuff away, and we'll get this monitor stuff out of the box. Here is the high voltage cage. Sent along the two heat sinks. And I did have him send everything except for the tube, because we need to go over everything. Make sure everything's good, all the connections are good, everything. And here is the chassis board. We'll unwrap that. Get this box out of the way. There's our chassis. Okay. So we have here. Okay. We have this here. Okay. And these solder joints look sorry. We need to resolder those joints. And that needs to be resoldered, the main connector. So yeah, just basic maintenance. We need to do our basic maintenance. We'll replace the voltage regulators, get rid of the tantalum caps that like to explode. We'll test all of these transistors in circuit. Replace these caps. These are, yeah, why not? Okay. Just kind of go through and do that basic stuff. This one needs to be resoldered. First thing I'm going to do is kind of go over put that in diode check so that you can kind of see, right? And I'm going to go over just some of the transistors in circuit. Okay, this is an NPN. No, that's a PNP, isn't it? Yeah. That's a PNP. This is the NPN. Okay. And this one is PNP. Okay. This one is also PNP. That's no good. That is definitely no good right there. Yep. This is a PNP transistor. This is what it should look like. And then over here on this PNP transistor we get this. That's no good. That one needs to go. This one's NPN. And that's no good. Yep, that one's no good either. This one's PNP. And that's reading a complete short. Yeah, these are no good. And this is the vertical section of, or is it? This is the vertical section of the thing. These were the ones that were no good. So what I want to do is pull these three guys, and I'm going to write on them. This one is this is P, this is P, and this is N. You have two PNP transistors and an NPN transistor, and they all seem to read no good. So what I want to do is, and these aren't bad. These resistors are not burned up. This one got hot, but they're not fried. So I'm going to pull these transistors, all three of these, and check them. I'm going to get the desoldering gun out, remove those guys, and then we'll look at them out of circuit. Okay, while the desoldering gun is heating up, we're going to look at the transistors in these heat sinks. Okay, so let me kind of move this out of the way, and we'll look at these. This one I believe is on PN. So let's do this on the base collector. Yeah. Okay. So far so good. Make sure it's not shorted any other way. That one's okay. Now we're going to look at this PNP transistor. These are the main deflection transistors. That's okay. And that's okay. And we'll make sure we're not shorted emitter to collector or bad emitter to collector. Those seem to be okay. Now let's look at the other one. First we'll do the NPN transistor. Good. Good. And then check emitter to collector both ways. Good. Now let's look at the NPN or PNP. Good. 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 And good. So the heat sinks are both good. Yeah, those are both fine, so we don't have to worry about that. And now our transistors should be okay. Sure, this thing should be ready to desolder. So let's back this up a little. Okay. And get these out of here. One. Okay. Now we're going to give these a test out of circuit. They all read weird. They all read no good. So see where we're at here. Move that. Okay. Let's do some tests. This is a PNP. Okay. PNP. These are hard to test. The leads are so small. Yeah, that's kind of open. That is... Okay, this is base in the middle. Collector is the case. So this is base to collector and base to emitter. So this thing's basically shorted. Now let's check the other PNP. Base to collector. That is short. Base to emitter is open. Yeah, wow. And this is the NPN. Red lead on the base, and then black lead on the collector. That's okay. And then we go with the black lead to the emitter, and that's okay. So let's go emitter to collector. That's okay, and then other way. So the NPN one actually looks okay. When you go base to collector, you get the drop, and then base to emitter, you get a drop. Okay. And then nothing from collector to emitter. I don't like this. When I go collector to emitter, alright, it's not doing it now. I was seeing some stuff on the on the meter. Yeah, it's not doing it now. But I was seeing, I don't know, maybe I was just seeing things, I don't know. Yeah. Collector to emitter, you should get no movement at all. And that's collector to emitter. This is collector to collector. And this is collector to emitter. The lead's reversed. So the NPN actually looks good. The PNPs are shot. This is the PNP once again. Put the red lead on the collector, black lead on the base. You're supposed to have just a drop, a junction drop, and it's short. That's junk. And this one, the other one, you put the red on the collector, black on the base, and we get that. It's supposed to be 0.6, so it's almost short. It's not quite short. And then if we go black on base, red on emitter, we get the same thing. So this thing is really short everywhere. And then collector to emitter, we should have it open, and it's not open. And then if we put the black lead on the collector, red on the emitter, we get the same thing. So this thing is junk. Both of the PNP ones are no good. The NPN one tests okay. So we will put the NPN back in, but the PNP ones need to be replaced. So yeah, and apparently the the two PNP ones that were bad were affecting the reading on the NPN in circuit. But out of circuit it's fine. These two guys, the PNP ones, are no good. So we'll replace those. The heat sink transistors are fine. I'll go through, do some maintenance, replace some caps, do some soldering, and solder some connectors and stuff like that, and we'll be able to start doing some testing. Put monitor together, put board to it, and see what we get. Okay, doing a little testing here. I noticed a smoked resistor right here. This one was burnt up. And these three transistors, these are little preamps, were right next to it, connected to it. So I decided to just remove these three guys right here, and two of them are shorted. No good. And I'll show you that right here. If we move this, move that, those three guys right there. Okay, let's back up and pan up. Let's try this. Let's do this. Let's move this a little bit. Move this to right here. Try this. Okay. Here's those three transistors. They're all NPN. All three of them. Okay. So let's go ahead, and these are middle leg. It's the same as a 3904. It's base. No. It's emitter, base, collector. So the base is in the middle. These are all NPN. So we'll take the red lead to the middle, which is the base, and then come over to the emitter or collector. We should get a drop, and we get nothing. Well, we get that. It's like a short, a partial short, an almost complete short. And then if we go to base to emitter, it's hard to do this. Base to emitter is...
Did you call a while ago?
Oh, all right, getting back. Yeah, that was my dad. Yesterday was my birthday, and I turned 50. Turned 50 years old yesterday. And my dad is taking me out to dinner with my brother. And we're going for a prime rib dinner this evening. So he was just asking me when that was going to be, and I guess we're settling on 6:30. So, yeah. Anyway, back to this. If we put the red lead on the middle lead, I'm going to try to bend these down a little bit so this sets down there. And so base to collector, we get a partial short. Base to emitter, we get an open. collector to emitter, we get no reading this way, and we get no reading that way, but that's basically a shorted no good transistor. The next one, red lead on the base, black on collector, we get a good drop, and then we move the black lead over to the emitter and we get another good drop. And then always check collector to emitter both ways, collector to emitter, black on the, and then just swap them. Collector to emitter. This is actually a good transistor right here. That one's good. Now the next one, red on base, black on collector, we get a short, and then black over to the emitter and we get a short. Collector to emitter, we get this thing just doesn't want to sit still. But collector to emitter is a short. This thing's shorted all the way around. So that's why that resistor smoked. So even though this transistor is good, I'm going to replace it anyway. These are a dime a dozen, Those are 2N5210s, all three of them. So we'll replace those, replace the resistors. I'm going to check all of the, I'm going to just quickly check all of these diodes in circuit. And you know what, while I got the desoldering gun out, I'm going to go ahead and replace those 5210s on this side as well. Why not? They're super cheap, so why not? Although there's really no need to. I don't know. I'll think about it. But yeah, I might as well test these in circuit as well. These transistors right here. Make sure. I'm just going to go through and probe around on everything in this area, make sure that there's nothing shorted. So I'll do that and be back. Okay, so after doing some probing around on everything, I have verified that all of these transistors are fine. Everything on this side, and this is the horizontal side, this is the vertical side. Yeah, see, vertical, horizontal. So this thing obviously had vertical collapse, not horizontal collapse. It probably had a line across right down the center, right in the center of the screen. I'm surprised it didn't blow the circuit breaker. But anyway, I didn't test these. I need to test those. I will do that. These three guys right here, I want to make sure. Those are like protection transistors, over current protection. They monitor the current in here, so I want to make sure that these are good. And these are good. All these diodes are fine. I removed all of the tantalum capacitors. Every one of those is getting replaced. There will be no tantalums to explode on here. I've got all of the regulators, voltage regulators removed. We're replacing all of those. And I resoldered all of these connectors. I actually had to remove the old solder, flux it up, and solder new on, so that it took really good. So that's good to go. Yeah, so I just need to repopulate, and we'll be ready to start testing this thing. So yeah, I'm going to pop these out of here so that I can reuse these heat sinks. Put new transistors in, all new parts. So let me go ahead and do that and repopulate, and I'll be back. These resistors right here are the same as over here. These are identical circuits. So this is this guy right here is red, brown, or is that red gray? Oh, dang it. I'll have to read it. I don't know. It's either red brown or red gray brown. So it might be, no, yeah, 260. And then that one is brown, black, brown. That is a 100 ohm right there. So that one's 100. Oh, it says it right here. It says 100. And this one's 200. So that is red, brown, brown. You have red, brown, brown, and brown, black, brown. So that should be red, black, brown right here. This one's red, black, brown, which would be 201. Yeah, red, black, brown, brown, black, brown. So I'll repopulate that too. So, of course. All right, I'll be back. Let me get this all repopulated and we'll be back. Right. We are all 100% populated. Got my 100 ohm resistor. Now this is supposed to be a 200. I put a 220 in it. That's all I got. Battery's going to die on my camera. All the electrolytic caps have been put in place. Getting rid of all of the exploding tantalums. My new transistors here and here. And then these three guys. Everything else has been tested and it's all good. No problems. These, I tested these. They're fine. You know what I need to do is I need to look at that guy right there and make sure. It just got a little hot. I'm sure it's fine. Replaced the regulators. And I put the little, it's a 0.4735 volt cap that actually filters the incoming voltage to this. I put a 2.2 electrolytic just on the back side. It's just a filter. That's fine. And I've got an original. It's not original. Somebody put an electrolytic in there, 4.7. That's fine. So we should be good to go. So we will go ahead and get all hooked up and see what we got. First thing I'll do is I'll hook this up and power it off of a tube and make sure I hear deflection chatter in a yoke and everything. Then we'll hook it up to a tube and the whole 9 yards. Okay, I have this thing hooked up. I cleaned the bottom of the board where I did all the solder work. I cleaned it really good. And I've got my Starcastle board hooked up to it for testing. These are the original heat sinks, and we've verified that those are good transistors. Now I hooked this up, and while I was charging my camera, I fired it up, and one of the fuses down on my block down here, the third fuse, that one right there, would slowly start to glow. And I'd turn it off. And what I did was I replaced both of the DACs with good DACs. And now if I turn it on, and we zoom in and look at our fuses, we get no glow. Okay, and you can hear the hear it. That's the deflections working. Yeah, so it's working fine. One of these DACs is no good. One of these DACs is causing the fuse to blow. So what I'm going to do is swap one at a time until I find the one that's bad. So first I'll put this one in. I'll pop it right here. And then we'll turn it on and watch the fuse. And then if that's good, then we'll try the other one. And just watch the fuse. One of these is blowing the fuse. If not, both of them. We'll see. Okay, I swapped in one of the DACs. So we'll go ahead and fire it up and check out our fuses. It does not seem to be glowing. Okay. That's good. It would glow by now. If it was bad, it would glow by now. So let's turn it off. Let's remove this DAC. Okay. Let's put the other DAC in. Okay, and let's fire it up. Okay, apparently nothing is frying now. No glow. Okay, another thing that could possibly be, you know what I'm going to do? Let's turn it off. Maybe these DACs aren't bad. Let's just remove this. I cleaned the bottom of the board. It was terrible with flux. And I cleaned it, and maybe there was a little bit of a bridging action going on. I can't see. Okay. Now let's try it on again. Yeah, there's no glow. Should be good. I'm thinking possibly cleaning the back of the board fixed something. Maybe a short of some sort, I don't know. It's not doing it now, so it's apparently okay. So, next thing to do is just hook this thing up to a tube and see if we've got good Starcastle. And I gotta hook up the high voltage. We'll go ahead and do that. Alright, well, as you can see, it is not right. We have a severe issue with the pitcher. We have good deflection. That's not a problem. The problem just looks like the processing of the signal. So I'm going to start by replacing both of the DACs and see where that gets us. So let's do that. Let's pop a couple DACs in really quick. New ones. Remember, I got the original DACs back in it. So let's go ahead and do that. Well, I got it closer, but I don't think it has anything to do with the DAC. I think it's this socket right there. If I mess around with that chip, watch, I'll show you. I'll mess around with that chip. See this? That's basically just touching that chip. So I need to do some maintenance. What I'm going to do is I'm going to replace both of the sockets, all three of the sockets, and I'm going to remove socket and replace the 2 op amps. That will pretty much solidify this thing as being proper. That might have been why my fuse was slow blowing, because bad DACs will blow the fuse. So if the DAC isn't making good connection, as a matter of fact, let's turn it off. that can, I mean, that could cause a problem. So I'm going to do that. Just do some quick maintenance really quick. The good news is this is customer's high voltage unit, which is good. I'm using my transistors, my output transistors, but I've already tested his. His are good, and I've actually already ran it with his connected to it, and it's fine. So a little more maintenance, and this thing should be good to go. But his DACs are fine. These two DACs, I believe, there's nothing wrong with them. So that's good. We'll go ahead and do that maintenance. Okay, I got this work done. New sockets soldered in. And if there was ever a time to use machined pin sockets, this is the time for these legs. Perfect for these. So I got machine pin sockets for the DACs and new sockets for everything else. So I'll go ahead and put this all back together and give it a try. I'm going to put new op amps in it. I desoldered these, but I'm going to, for the time being, I'm going to put some new ones in there. I might, once I get this thing all fixed, I might pop these back in it and see if they're good or not. I don't know. Whatever. Anyway, yeah, so let me go ahead and put this thing back together. All right. This thing is working, but it's a little shaky and jittery. What I have found, and it's not my cable because I tried 2 cables now, and I know my cables are good, but I was just trying a little elimination. This connector needs to be replaced down here. That's obviously got bad pins in it or whatever, because if I just kind of play with this a little bit, see how it just flakes out? Just by kind of messing with it. See that? Yeah. I'm going to turn it off. So I'm going to have to replace these pins. So let me do that and we'll be back. That thing's just never going to be solid with those pins like that. So let's replace those. Okay, and we'll be replacing these old oxidized parts. Look how badly oxidized those are with the new shiny ones. Yeah. We'll go ahead and solder these in, and this thing should be good to go. There we have it. Brand new connector. Nicely soldered in and cleaned. Okay, let's go ahead and hook this thing up. All right. So it is working. And this cable here does have an issue. One of my cables just, I don't know, has an issue. But that was definitely an issue because even when I had my known really good cable hooked up to it, it didn't work. So that's just factual that this was no good. So this connector was just oxidized and was a questionable connection. Now, the one thing that I see here, and I don't know what this is all about, but I've seen this with multiple CinemaTronics monitors, and I don't know if this is a high voltage thing or if this is my setup, or because I've seen this more than one occasion. Is it's just kind of shaky, the player 1 and player 2. I don't know what that's all about. I don't know if that's... I don't know. I really don't know what that is. Is that possibly one of the DACs? I could try... You know what? Let's do it. Let's just try popping DACs in it and see if that straightens that up. I really don't know. So let me try that and we'll see. After replacing both of the DACs, it is definitely 100% better. It's not doing this anymore. Like going meh. The only thing that it's doing now is it's coming over here. And that's almost unnoticeable. It was this deck, I think, I don't remember. It was the one in the back. It was the vertical deck. That one right there. This one seemed... I changed this one first and I made no change. So I'm going to change that one back really quick. I'll be right back. Yeah. CinemaTronics is stable now. Player 1 is stable. Player 2 just kind of goes that way back and forth a slight bit. But it's 100% better than it was. This DAC is just no good. This, I mean, it's good to where you can put it in and it'll work. But, yeah, it just, I don't know, it makes it... Look at that. Now that's starting to do that. It's still stable here. It's almost unnoticeable. But honestly, I'm going to replace that other DAC once again because this is moving quite a bit. I don't know if you can see that very well. Okay, now I'm going to replace that DAC again. And we'll watch that player again. In the camera lens, it almost looks like you can't tell, but let me go ahead and put the other DAC back in. Okay, I just replaced that one again. I've got these oriented the way that they go in. This one is that way, this is that way. And I don't know if it's really pick-upable, but that is way more stable with this other DAC. These DACs are weak or something, or they're just worn out or whatever. I don't know. I mean, it's still not exactly stable. But it's better than it's better. I think I'm going to call it good with that. I think I'm going to send these, of course these will go back because technically they work, but they're jittery. They're really jittery. This one's worse than the other one. So I'm going to put a red dot on this one. This is the really jittery one. I'm going to put a red dot here, and then I'm going to put a green dot on this one, which it's better, but it's still a little shaky. But this one's really shaky. So, I mean, it works. Technically, it's good. But it's just shaky. So I'm gonna do that. They'll go back. Customer can keep them as backups. But this is way more stable with those other DACs. All right, excellent. I'm going to call this one good right here. I'm going to let this thing run for about 3 hours and make sure it doesn't crap out. And that's going to do it. As always, thanks for watching, everybody. And we will see you on the next Classic Arcade Repair. Bye for now.